So in a few minutes, hopefully everyone here will be the best in the world on how to solve the problem of an agreement getting stuck halfway in an agreement chain of people. And Mikael mentioned I invented what he called the gradual approach, but that's half true because Ryan Fugger invented it in 2006 already, and I will explain what it is. But what happened in 2006, I think, was that Ryan managed to come up with the same idea that I've been finishing now, but he got stuck after about 75% of the way, I think. I was thinking we would do a history of ideas approach to this. And Mikael has been working professionally and non-professionally also probably. You'll be working with Ripple and Interledger and probably many do-it-yourself projects. Like my own project is non-professional, that's what I mean, just some dude. And you have all been building up the infrastructure and developing the ideas for 20 years, and before that, for 100 years. Hans Florian is an expert on the history of ideas when it comes to those 100 years. And before that, as someone was giving a present, was maybe Hans Florian that, 300,000 years ago. So there's a history of ideas. And if my idea is any good, everyone should be able to pin it into the history of ideas and say, there's a logical continuity. And if my idea is not any good, you should all be very confused and forget about it. Move on with your lives. So hopefully, we will see. And the problem is not entirely intuitive, because we don't encounter it always. I will use cycles as an example. Is Thomas here? In cycles, cycles does a lot of things in a decentralized way, person to person, but then there is one problem that arises where it has to do it all in a centralized way. So you have to, you're doing it person to person, and it's a free grassroots community, but then you kind of have to fall back on the dictator or the central authority or the king or the state or the central server. And because we typically fall back on that, we're not aware of that the problem even exists, because we're just taking for granted it doesn't exist, because it doesn't exist when we've delegated a central authority to the problem. And the best way to think about it might be to think about a chain. So not a chain of people. And a chain is only as strong as its weakest link, right? So if you have 100 people, a single person could destroy that system. Usually in communities, a single person can't destroy an entire community, but if the community is a chain where every individual relationship link in the chain is not able to communicate or see anything else in the chain, then a single person can destroy the whole thing. So we don't typically think about that because we typically don't organize socially in such a way. What we typically do is, if there's 1 in 100 that's maybe wanting to not work with the group, we typically find one of the other 99 and we place them above the group and we coordinate via them. And this could also be a blockchain in modern days.
That's a referee approach, right?
Yeah, I'm just generally that to see the problem, you have to see the context of the problem. And we don't see it typically because we rarely work with such systems. And when it comes to payments, the problem is that when you do the payment, you're typically competing when you do it in a network of nodes that are finding payment paths via via liquidity to the next relationship they have, the next hop. And because there's competition, there's a race condition where you would need to, if I want to make a payment through a certain path, and I ask them, do you want to all do this payment now? And they typically have to reserve the amount of money that they want, that I ask them to use for the payment. Because otherwise someone else could come at the same time from another direction and ask, do you want to use this money? So you have to initiate the payment by promising the money to the payment. And that's where we run into a problem within the chain of people, that a single person can cause this signal, this agreement to get stuck, because they can choose to do nothing. They can also choose to send their own signals, but that's another problem. That's the cryptographic proof of delivery problem. So what do we do? For example, how is that resolved that you ask everyone, do you want to do this? Everyone puts money away, a single person causes it to stop, and everything is stuck for all eternity, and everyone's money is locked for all eternity. You have to time out the payment. And that was the solution, and Ryan Fugger had that 20 years ago. But when you time out the payment, you introduce the risk of a penalty in the payment, in all scenarios. Typically you do it in 2 phases. So you ask everyone, you want to put away your money, otherwise we won't cancel, and then you kind of finish the payment. And if it cancels here, this person gets stuck with the payment. So when you solve the problem of reserved credit getting stuck because of an attack or a network failure, but in attacks there's a trillion or million times higher risk, you introduce another issue, which is that you always introduce a penalty. But you always introduce this penalty only on one of the phases. And when I say always, I mean that when you use a timeout, you can either cancel the payment, which is what everyone has been doing for 20 years, or you can finish the payment, which is what I was doing. So in the history of ideas, I was ignoring the history of ideas in advances on how to solve on multi-hop payments, and I just built my own system for a year now. And then my approach was to finish the payment on timeout, and yours was to cancel on time. Everyone else which you have worked with, and you have to combine them. And I will quickly show this here, that when you do the 2-phase commitment, you cancel on timeout, and this is on my website, anyone can download it. There's no penalty on the first phase, there's a penalty on the second phase. And when you do finishing on timeout, there's a penalty on the first phase, and this has to do with that when you finish on timeout, the penalty is on the person with an outgoing balance but no incoming balance. And when you cancel on timeout, it's on the incoming balance, it's on the person who has an incoming balance but no outgoing balance. So they're opposite. So there's a penalty on the first phase, motivating the buyer to cancel unless the initial prepared phase fails. Otherwise the buyer is penalized. And then you can ensure that that will always succeed or cancel, or because of the enforcement. And then on the second phase, when he said the buyer knows everyone agreed because they have gotten this signal, everyone else has to be informed, and then there's no penalty. This doesn't matter if the timeout is very short, like a few minutes, but now we come to the solution that Mikkel mentioned I came up with. If you want to do, instead of having the risk of an innocent person getting stuck with the full payment, an intermediary participating has to pay $10,000 for someone else, you can make the penalty gradual, so that every timeout, every 5 minutes, you pay $1 of the payment. Or every nanosecond, you pay 1 million for $1. And this is an obvious solution, I think. So Ryan Fugger came up with this idea in 2006. But the problem is that when you do it slowly, you tend to have many timeouts, and the total duration tends to be much longer than when you do a single timeout, 5 minutes. It could be, he was talking about daily penalty rate. So it could be a month for $10,000 maybe. And then, when you do that, the original timeout mechanism to resolve the reserve credit attack no longer works. And you only have the penalty working. So you had a problem, the reserve penalty, reserve credit problem. You came up with a solution in the history of ideas, a timeout. It introduced a problem, or a thing, a penalty. The penalty needed to be solved by reducing the size of the penalty. When you do that, you undermine the original solution to the original problem. So what you need to do then, as the next step to finish where Ryan got stuck around 2006, is you need to have a penalty on all phases. And that's where you recognize that in Ryan's approach, that interledger was started from, there's no penalty on the first phase, but there's one on the second. In my approach, when I was stubborn and did not listen to what everyone else had come up with, and I wanted to do it myself because I was thinking, no one seems to know what's going on here. No one has built this, it's been 20 years. I had a penalty on the first phase, but not on the second phase. So if you combine this, and this is very easy to see, so from a history of ideas perspective, anyone could do this themselves, in their heads with ideas, with the executive function, and you play with ideas. You combine them so that the finish on timeout is here, and then it leads into the cancel on timeout here. And you switch the timeout behavior, and to switch the timeout behavior, you need to add an intermediary step where you switch the timeout. You agree to switch the timeout behavior from the buyer to the seller, and it leads into this one. And there you have a penalty on all phases, so you can do slow-acting gradual penalties of 1 million for $1 per nanosecond or anything else. No one has a risk of getting disproportionately punished as an innocent person if your server is offline for 30 seconds or there's a DDoS attack on your server causing it to be unresponsive for 10 minutes. You don't end up paying thousands of dollars for somebody else. You pay maybe half a dollar, 100 of a cent. It just makes the problem irrelevant. And Ryan truly understood that you needed slow-acting penalties. There's pages after pages of writing on his wiki about it. But then, anyone can see in the history of ideas and innovation, you have a problem, you come up with a solution, it creates a property that can be a problem, you solve that problem, you undermine the original solution to the original problem, and then you need another solution. It's easy to see you would get stuck. And in an indirect teamwork with Mikkel, who I've been bouncing this with in email, and with everyone who has been building the infrastructure of the idea of the cancel on timeout, which is millions of people. It's the Lightning Network in Bitcoin, it's Ripple, right? Stefan was working with Ripple since 2005 and many people here. Because they all developed half the solution, and I was, stubbornly thinking I'm going to do it myself. I accidentally came up with the other approach. There's exactly 2 ways to use a timeout, cancel or finish. Because the other side, so to speak, the people who believed in the cancel timeout, they were very critical of my finish on timeout. They said, this is not a good system. You don't listen and you don't understand computer science. You believe you are a genius, and they said many things. And they were right, because my system is mediocre, theirs was mediocre, and we need to combine them. So it's a teamwork.